Okay, this hour we will go to the second chapter, application layer. Um, let's see. In this chapter, we would like to introduce several different types of network applications. We have two major application architecture, which is client-server architecture and peer-to-peer architecture. So we'll introduce what is the difference between these two application architectures and what is the pros and cons. And then we'll introduce several different important net application layer protocol, which is a web HTTP protocol, email, its corresponding protocol is SMTP and MIP, and the most important things, which is domain name system DNS protocol. And then the last one is we will introduce some concept of P2P applications, which is one of the application architecture. Okay. So right here, in this chapter, our goal is to let you understand what is the aspect of application layer protocols. And of course, because application layer protocol is served by the underlying transport layer protocol. As we mentioned in the chapter 1, we have service model, right? So we will talk about some interface between the application layer protocols and the transport layer protocol. So I will teach you the service model. And then, as mentioned, we have two important paradigm, which is application layer structure, architecture, which is client-server model. I believe you have heard of client server before. And the other one is peer-to-peer, which is P2P paradigm, okay, which is also an important paradigm that you can design your applications. And at the right-hand side, we will learn about protocols by examining popular application layer protocols and infrastructure. And but those protocols are relatively, old or classic. In 1999, we have HTTP, which is hypertext protocol, which is used by the web pages. Okay, web server and between the web server and your browser. That is how they communicate with each other using HTTP. And then the email. We have several different email protocols. We introduce SMTP and MIP, but they are relatively old protocols. But in this class, we'd like to teach you how those researchers, how those experts design their protocols. What is the rationale they design this protocol? What is the pros? What is the cons? How do we use text-based protocol, or we should use binary-based protocols? Something like that. And the last one is DNS. DNS is very important because it helps us to create the CDN, as we mentioned before, content delivery network. So I think this is very important, and it's also a very important supporting protocol that helps us to convert IP and domain name. Okay, and then the last one is the programming network applications. We will teach you how to write network enabled program. In your first grade year in the MIS department, I believe you have learned Java program, but those programs are simply just teach you how to do the logic and how to do the input and output, right, in the file. But the network program, which is called socket programming, is a little bit different. So we'll teach you how to do that. But we will postpone this part after midterm. So we skip this part in chapter 2. We will we already have some videos that teach you how to write socket programming using Java and Python. So we do this project after midterm. Okay, so here you can I'm not sure how I'm not sure if you're familiar with protocols. So let's take a look at Internet Protocol on Wikipedia. Okay, so right here, and you can see that at the right hand side, okay, there's some Internet Protocol Suite. Okay, and you can see that those protocols are layered. Okay, as we mentioned in the first chapter, application layer has tons of application layer protocols. Okay, maybe you are familiar with, for example, DNS, FTP, HTTP, HTTPS, or some other protocols. We will talk about some of them in this chapter. And transport layer protocol, I believe you have already know TCP and UDP. But however, we have even more transport layer protocol, but we don't use those protocols that often. And internet protocol, we currently have IPv6, IPv6, but currently most of the PC in the campus or in your PC, we use IPv4, Internet Protocol version 4. But gradually we will migrate to IPv6, which is more flexible and the scalability is much better. So the link layer right here, tunnels, PVP, or MAC, this is a very rare thing protocols, but usually we use Ethernet, we use Wi-Fi, we use fibers, something like that. We'll introduce this protocols in the later chapter. Okay, so if you're interested in different protocols, take some time to take a look at this Wikipedia page. Okay, so and again, if you're interested in early network and application, there is a novel called The Cuckoo's Egg. Okay, maybe you can buy it on the internet, or you borrow it from the library. It is a very interesting novel. It talks about in maybe late 1970s or 1980s, when only a very few people know what is computers and what is computer network. And at that time, there's a security incident has been observed in the university. So the computer scientists, they're trying to figure out how to figure out who is the attacker. But the attacker is a student in Germany, but the attack happens in the United States. So they have to use different techniques. They have to trace trace how the attacker attacked the computer system. So I think if you're interested in early network application, I think it is a very nice novel for you to read. Okay. So there are several network applications. I think you are very familiar with those applications: social networking, web, text, email, games, video streaming, sharing, video conference, something like that. But I think usually those protocols are invented in has different purpose, of course. But as I mentioned right here, originally the earliest earliest application protocols, they are text-based, right? Something like HTTP, that basically they are text-based protocols. But with the when we would like to use multimedia, we like to see view graphs, see pictures, see colored text on your web. So after that, people invent different protocols that can transmit multimedia data. Okay, so you can embed files, you can embed images in your email. You can even further stream videos, so that you don't have to download or upload the entire image or entire video at the first beginning. You can continue receiving the media and display the media. Okay, so gradually the network application become more and more complex. But in this textbook, we believe that teaching you the classic application protocols, most of them are text-based. I think that is very important things. You have to know what is the rationale to use text-based protocols, what is the rationale you use the binary-based protocols. What is the rationale? You design peer-to-peer architecture, or you use client-server architecture, something like that. Okay, the next one is creating network applications. So that you can see that is a network edge, right? We have several different client, which is the for example your cell phone, your PC, and here is server at the right hand side, right? Server right hand side. So there are two clients and one server. Okay, so writing a network-enabled program. Of course, those programs are run on different end systems, at the server and at the client, right? So those applications need to communicate with each other over the network, no matter what kind of routing protocols used, no matter what kind of data link layer, what kind of physical layer they use. It really doesn't matter, because when you write a network-enabled application, the only thing you care about is, of course, your logic, your programming logic. And the second part is the API. There are several different API. There are several network library. So in the operating system, so that no matter you use Python, you use Java, you use C# to write your network program, there's always a library, network library, that helps you to communicate with the remote applications. So simply just like when you write print in your program, no matter it's Java or C, basically you don't know how operating system communicate with its hardware, and its hardware, for example, is the monitor can print hello world on the screen, right? Basically, we don't know what is the mechanism in the hardware in the operating system. But as long as we know, we include certain libraries in C or Java, and we just simply invoke those function, and this function will help us to print hello world on the screen. It's very similar to the network application. Basically, we don't have to care about how routing works. We don't have to know how Wi-Fi works, how those wired copper wired, how those electromagnetic wave works. We don't have to know that, because those libraries will provide an interface, which is the API, so that we simply just call those APIs so that the message can be delivered from our application layer to the underlying transport layer. And after that, it is none of our business. Transport layer will know how to communicate with network layer, and so on, so forth, to the data link layer, and to the physical layer, to the destination, to the server. So I think that is the basic idea. It is very similar to writing a common general program. Okay, so in the communication, usually we have two roles. One is called server, the other is called a client. Okay, for example, web server and web client, and web client is your browser, right? Basically, we have these two roles on the different side of the network. Okay, so the second part is the second bullet is no need to write software for network code devices. We don't have to care about the physical link layer, physical layer, link layer, network layer, or network code routing problems. Okay, so there is a boundary, there is a clear API interface between your program and the underlying architecture. Okay, so that is this page. So here we would like to talk about application architecture. Okay, the first one is called client server paradigm. Usually we use another word like a bank paradigm or a procedural paradigm, because in bank and procedure are built in certain fixed place, right? A lot of server work in the procedure, work in the bank, or work in the procedure. Users has to go to the bank and go to the procedure to get the services, right? That is what we call client server paradigm. So there are two roles. One is server. Server is an always on host. It never turns off the power. Okay, because servers should be right there at a permanent or fixed IP address, so that people, well, I mean user can know where to find those servers, just as you know where bank is, you know where procedure is, because they have fixed address, right? So, however, most of them are currently in data centers. They have very nice air condition because very nice condition. They have a very nice a bandwidth, right? Because they are well take care of, right? Okay, those are servers, and the other side is client. Client is the one who initiate the communication, just as you go to a bank, right? You have to approach the bank, right? So client communicate with the server, okay? Maybe intermittently connected, because server, as mentioned, server is right there. It's always on host. It has a permit, fixed IP address. It usually it doesn't turn off its power, right? But for the client, okay, you can, for example, my laptop, I can go to campus, I can connect it to the Wi-Fi, I can go to Google to request some service, and I can turn off my laptop and go back home to connect to my home cable network, and then send a request to Google server. So it can intermittently connect it. A client is not necessary to be an always on server, always on host. Okay, maybe have dynamic IP address, right? You can get the IP address from the campus Wi-Fi. You can get the IP address from ADSL modem, from cable modem, or you can get it from your 4G, 5G network. It really doesn't matter what IP address you use as a client. But as a server, you should have a fixed IP address so that users can find you on the internet. And the other one is important, that do not communicate directly with each other. For example, there's a browser right here, right? So that is a web server. And the other browser is right here. Usually browser talks to web server, browsers talks to web server, but you never do this. Browsers never talks to browsers. So they do not communicate directly with each other. Okay, I think that's a very simple concept right here. So I think students may familiar with client-server paradigm. So I would like to talk about P2P architecture right here. I think maybe in early 2000s. Okay, let's go back to here, to the client-server model. Okay, if there is a web server at the right hand side right here, okay, for example, is selling very popular ticket, okay, ticket. So take selling web server. So sometimes, okay, a lot of users, a lot of clients would request service from this web server, right? For example, there's a popular concert, there's for example, it is Christmas time, so people need to get a plane ticket, something like that. So sometimes lots of requests from different hosts, different clients will send request to the server, request for service, right? However, as we mentioned before, although those servers are well protected, has large memories, has large computing power, has larger bandwidth, but those resources are limited. So if really we have too many requests from those clients, eventually those resources for bandwidth, those memory, those CPU computation power, those storage space, they will be consumed by those large amount of clients. So in this case, the server might not be able to serve new users or even those tons of users has already sent a request. In this case, we call it DOS, denial of service. DOS, denial of service, because all the resources has been consumed. The server has no available resources to serve the new users. So I think that is the most disadvantage of such kind of communication paradigm, client server paradigm, because for this server it is very easy to call to we use this word called single point failure, because all this service relies on this specific web server. So if this server has been attacked, this server has consumed all of these resources, something like that, and then no any user can request the service from this server. So it is very dangerous. So in early 2000s, okay, there's another popular architecture which is called P2P. Okay, we use P2P. Okay, P2P architect. So in this kind of application architecture, they has no always on server, because this server is too we use the word too vulnerable. If there's something wrong with this server and an entire service breaks down, right? So in order not to having single point failure problem, so we don't have always on server. In contrast, okay, arbitrary end system directly communicate with each other. That means at the right hand side, each circle right here is a peer. Okay, it's a peer. So right now we don't use the client or server as the role. Okay, we use the word peer. Every peer can communicate with each peers. Okay, so the next one, peers request service from other peers. So if there is a file, for example, if there is a file right here, okay, it is on for example peer A, B, C, D, E. Okay, so there's a file on peer D, and peer A want to access this file, so it can send a request to peer D. Says, okay, I would like to download this file. So D will provide this service, file sharing service, to A. So this file can be copied to peer A. So here, peer A get a file. And then it's very important right here. This peer can provide service in return to other peers. That means, for example, if peer C would like to download exactly the same file, it can download the file from A and from D. Okay, so in this peer-to-peer architecture, everyone can be your server and everyone can be your client. They can serve others and they can get service from the other peers. So in this case, we a very important feature is called self-scalability. New peers brings new service capacity, okay, as well as a new service demand. So in the early 2000s, when people like to download MP3 music or movie from the internet, a lot of different peer-to-peer applications are in the market. So everyone can download those peer-to-peer network applications and share some files on the PPP networks. Okay, when more peers join the PPP network will be more robust. Okay, but there's one thing right here is that peer can intermittently connect it and change IP address. For example, the peer A right here. Okay, maybe sometimes it use Wi-Fi network to connect it to the PPP network. But after it connected to the network, it has to do some what we call registration. Okay, it has the peer A. Okay, after connected to the peer-to-peer network, they have to do registration or to do some kind of announcement. Say, okay, I'm peer A. Currently, I have a new IP address and I run certain version of the PPP network applications and what kind of service I can provide. So the neighboring peers can know, okay, we have a new peers online right now. That is peer A. Peer A can also turn off its PC and go back to home and get another new IP address and again turn on the application. And A has to do the registration again. Okay, I'm A. I have new IP address and my application version is 1.5 and I provide some services. And if you want my service, you can download files or download and request service from me, something like that. So the entire PPP network is a little bit dynamic. Sometimes A is online, sometimes A is not. Sometimes A has a fixed IP address, sometimes it has a dynamic address. It really doesn't matter. However, to do such kind of management is rely on the PPP application layer protocol, so that everybody knows what kind of service is online right now and how many peers are on the internet. I think in early 2000s, a PPP network can have more than 100,000 of peers in a single PPP network. Okay, I think of this PPP network. We will talk about PPP network later in this chapter. So it is just a concept. Okay. However, to run the PPP application in your laptop is there are some challenges. The number one is ISP friendly. As we mentioned before, the access network, for example, ADSL or cable network, they have a symmetric download speed and the upload speed, right? Because they believe we have more requests for downloading things from the internet. So we have a bigger download bandwidth. We have a smaller upload bandwidth, right? But in PPP application, you can provide, you can pull files from others, right? You can also upload files from your peer to the internet peers, right? So usually we have a smaller upload bandwidth. So if you provide services at home and somebody download those files from your home network, and it may congest your home network because you have a smaller upload bandwidth. So it may cause a problem in the early days. But currently we have a bigger home access network, right? We maybe 100 megabit per second download speed, 40 megabit per second upload speed. It is relatively larger in early than the upload speed in early 2000s. So I think it is okay right now. However, due to the because as no students like usually we don't download those illegal movies or MP3 files because it is now quite convenient for you to subscribe, for example, Amazon services, HBO services, Netflix services. So it is quite cheap for you to get those services, okay, legally, of course. So it's right now it is not necessary to install such kind of P2P P2P applications to spend some time to download those files. Okay, so P2P architecture is not that popular right now, but we'll teach you where we can use such kind of architecture. Okay. The second challenge is that security, because the file sharing services on the internet, you share files with somebody you don't know, so it is quite risky. Sometimes you believe you download an MP3 music, but actually it is a malware, malicious software. So it is not guaranteed the file you get is very normal, is harmless. So it has P2P application usually has some security concern. Okay, and the third one is incentive. Because you have if you download files from the others, okay, you also need to provide your bandwidth to upload files to serve the others, right? But there are always some free riders. They simply just want to download files from the internet and do not want to provide service to the other peers. So after the files is downloaded, the peer can turn off the application, right? So there are lots of free riders on the P2P network. So it is not it is a challenge for P2P application, because too many free riders may the self-scalability will not sustain if too many free riders right here. Okay, so that is the P2P architecture. I think we will talk about P2P application at the end of this chapter. So it's just a concept right now. So I would like to stop right here, and let's take some time to take a look at the homework. Okay, this is the first time this is our first homework. So make sure you use your Google your g.nccu.edu.tw account to register in the Google Classroom. The group our class website has two codes, one for Tuesday, one for Wednesday. Okay, make sure you join the correct class. Okay, so we have announced the Google homework number 1 in the Google Classroom. You can see that. So for Tuesday student, okay, the due date is October 4th. For Wednesday student, that is October 5th. Okay, so because this is the first time we use Google Classroom, in case you have some problem, in case we have some technical problems, so actually homework number 1 has no due time. Okay, in case of any problem. So I'd like to go over this homework problems. The grade, how many points you get in your homework, it depends on the quality of your writing. Okay, you have to let TA know that you really know what exactly the answer are. Okay, so for example, what are the pros and cons of DSL and cable access network? So basically you have 4 different things you need to write. Okay, the pros of ADSL, so you write what you have learned in the textbook in our lecture. Make sure you write enough sentences so that TA you know all of the pros of ADSL technology, and so on and so forth. And the second one is the pros and cons of wired and wireless. Okay, make sure the quality of your answer deserve those points. Okay, so the third one is, what is the reason why application message must be fragment? So basically, you have to talk about The reason why we use the message have to be fragmented because we believe packet switching is much better than circuit switch, so we do fragmentation. And because we cannot send, for example, 1 million, 2 million bits in a very short period of time, so the the best strategy is to fragment those big messages into small chunks. For routers or for the source and destination, we send one chunk once a time, right? So if there's something wrong on the router, for example, the packet has been dropped, packet loss, noise, interference, something like that, only part of the messages, some packet will be interfered, will be affected, so that we can retransmit those packets. We don't have to retransmit all the entire messages, for example, 1 million bits or something like that. And packet switch is much more efficient than circuit switch. So it depends on what have you learned in our lecture, in our textbook, and just write down what you know, which is related to fragmentation of messages. Okay? And of course, the quality is important. You cannot just write something nonsense and get point. It is not, TA is not, TA will not give you a point if you write something nonsense. Okay, and sometimes we have you have to do some mathematics. Okay, so make sure you understand the problems. Okay, this 3 is related to delay. So as we mentioned before, there are 4 types of delay, right? So you have to calculate the transmission delay, the propagation delay in different hops, the process delay, and queuing delay. And it depends on the problems. Sometimes we don't have queuing delay or process delay. You simply just write down what kind of delay you have and how do you calculate by using these numbers. The answer is not, the actual answer, the actual number is not important. The important thing is how do you formulate those delays. Okay, number 4 and number 5 are all related to delays. Okay, I think the number 5 is that we do voice over IP. So the voice signal are 64K bits per second on the fly, and each packet is 56 byte per packet. Okay, and assume you have a 100 megabit per second bandwidth and average delay. You can here you can see that we give you the propagation delay is 100 milliseconds. Okay, you simply just use this number. You don't have to know where it comes from. Okay, and so that the question is, how long does it take for you to wait for the very first voice response from your friend? Okay, so you can calculate the one-way delay, right? The delay includes the propagation delay, includes the bandwidth, so it includes the transmission delay. Okay, by using this 60K voice signal, and each packet is 56 packet. So it takes some time. So just list them as possible. Okay, that's our delays. Okay, number 6. Okay, we have talked about how to calculate circuit switch is much worse than packet switch. So there's some other numbers. So we have 3 megabit per second link. Each user use 150K bit per second bandwidth, and only 10% of active time. So the rest of the question is the same as we shown in the lecture, right? If you use circuit switch, how many users can be used in such kind of network environment? If you use packet switch, what is the probability of having, I think it's 120 users, something like that. Just simply write down this formula. You don't have to calculate the actual value, because TA knows you know how to formulate those answers. That is good enough. Okay, so make sure you write your answers, or you send a PDF file to the Google Classroom, and TA will grade your homework. Okay, I think that is okay. So we stopped right here. So next week we'll continue application there.